This is 5.4a, binomial probability distribution. So we're going to spend quite a few days actually dealing with this topic. This is the biggest topic within this chapter. So we're taking probability distributions like we talked about last time. Now we're looking at binomials. That is something with two possibilities. Okay, and you'll notice a lot of the questions we're going to look at are very similar to questions that we looked at last chapter. Okay, so create the probability distribution for a 4-question quiz with answer choices A, B, C. Let X be the number of correct answers. So if it's a 4-question quiz, I can get none right, 1 right, 2 right, 3 right, or all 4 right. Okay, so now we need the probabilities for each one. So probability of getting 0 correct. Well, we have 4 questions, so 4 fractions. And then we have combinations. I want all of them to be wrong. So I'll use a W to represent wrong. So what's the probability of getting this wrong? Well, my probability, I have 3 answer choices, so 2 out of the 3 answers should be wrong. And then I have 4 questions, and I went 0, I have defined, we'll say 0 correct. Related to that thing. So I've defined all of them to be not correct, basically. So none of them to be correct. So that's why it's 4C0. You'll see why I'm kind of changing this. A lot of people want to say 4C4, which would actually give you the same answer in the end. But how we're going to deal with it as we move forward is we're actually going to use the 0. You'll see. Okay. So anyways, I'm going to leave this in fraction form. So 2 times 2 times 2 times 2 is 16 over 3 times 3 times 3 times 3 is 81. So 16 out of 81 is that first probability. Then we have to do it again. Now is the probability of getting 1 correct. So I'm getting 4 fractions, combinations, 1 of them correct, 3 of them wrong. It's a 1/3 chance of getting it correct. 2/3 of getting them wrong. 4 questions, 1 correct. Multiply across, and we will get 32 out of 81, which that is actually the most likely outcome. Probability of 2 correct. You can see this is going to take a while, especially with larger problems. So we're not going to do a ton of these where we're finding every single piece. But this is going to relate to, or lead to, which is finding more than 1 at a time. Okay? So we get 24 out of 81. That's 2. 2 correct. Then we have 3 correct. And that means 1 wrong. So 1/3 chance of getting it correct. 2/3 chance of getting it wrong. 4C3. And you multiply and you get 8 out of 81. And finally, we get to the last one, which is all 4 correct. So I want all of them correct on this one. It's a 1/3 chance for each one. And I have 4 questions, 4 correct, 4C4, which is 1 out of 81. And there we have it. We have completed the probability distribution. It took a while. We're getting a little more complicated with our things. It's not just like, oh, think about it, coin flip, half and half, easy. Die roll, 1/6 each, okay? Getting more complicated. So let's talk about the binomial probability distribution. So to be binomial probability distribution, you need n repeated trials, meaning you have to be doing something more than once. In this question, we did it 4 times because we had 4 questions. Okay, so each question represents a trial. And that makes sense. If we think about the probabilities here, right, each one was its own little piece. I have to have only two possible outcomes. That's what makes it binomial. Okay, the fact that it has two, a success or a failure is how we call it. Okay, a success is not necessarily the good thing. Don't assume it's the good thing. The success is the one we are looking for. Failure is the opposite of what we're looking for. We have variables here, so I'm going to actually highlight these guys. You have the probability of success, which is p, lowercase p. You have the probability of failure, which is lowercase q. And then you have another equation which says that those two are going to always be complements. And you could see that on this question. 1/3 for correct, 2/3 are wrong. Add them up, you get 1. Okay? And then the last thing is a random variable x. So your outcomes count the number of successes. So, right, in our table, we had 0 successes, 1 success, 2 success, 3 success, and all 4 successes. Okay, so we can see we already understand this. We've already looking for this. So, example 1. 10-question quiz with answer choices A, B, C, D, E. So 10 questions, that means 10 trials, 5 answer choices. If we're looking for correct answers, that is important. What are we looking for? That is considered a success. Find P and Q. So a success is a correct answer, which is a 1/5 chance. A failure, which is a wrong answer, in this case, is a 4/5 chance. On the next question, we're looking for wrong answers. So a success now is getting a wrong answer. A failure is getting a right answer. So notice how important picking out the success versus the failure is, because that is a big difference, right? 4/5 versus 1/5 changes significantly. Okay. Example 2 is using one of those properties. It always adds up to 1. So if my probability of success is 1/10, my failure, Q, must be 9/10. So if they give you one of these, they're giving you both. You have to recognize that. If they tell you the success or the failure, you just subtract from one, and that will give you the other one. Okay? And then we get to the binomial probability function, which is another important thing from this. But binomial probability function right here, I'm going to box it, put a star next to it. You're going to be using this thing a lot. It's a probability function. P, the success, to the power of x, times Q to the power of n minus x, times NCX, where P is the probability of success, Q is the probability of failure, N is the number of trials, and X is your particular outcome. So question 3, example 3, find 10-question quiz with answer choices A, B, C, D, and X is the number of correct answers. So that's an important thing. We are looking for correct answers. That is what's considered a success. So let's define these things real quick. We need to define P, Q, and N. A success, a correct answer. It's a 1 out of 4 chance. A, B, C, D, one of those is correct. That means my failure must be 3/4. The number of trials, I have 10 questions, so there we have that. So for every question we relate to, P, Q, and N are defined as that. To find the probability of x equals 3, we have to use these values and this equation. So it's the probability of getting 3 correct, exactly 3 correct. Okay, which should sound familiar. We've actually done this before, but now we're going to use exponents. So a success raised to the power of x. So I want 3 successes. That's what we decide. We want the probability of getting 3 correct answers. That means I'm going to have my failures, and then we subtract n minus x. 10 minus 3 is 7. And notice these should always add up to your total number of trials. 3 plus 7 is 10. So a good way to check you did it right. Times n, which is 10, cx, which is 3. And we type that into our calculator. And whenever we get, I'm going to convert to percentage and round to the nearest tenth of a percent. So I get 25.0% if I type that in. About a 25% chance of guessing and getting 3 correct. Okay, now what if I've said exactly 8 correct? Okay, so I want 8 correct answers. 1/4 to the 8th power times 3/4 to the 2nd power, 10 minus 8, times 10C8. Type that into your calculator. And you'll notice you get a very, very small answer. If I'm going to write this in a percent, it's 0.04%. So you have a 0.04% chance of guessing and getting 8 out of 10 correct on this quiz. This quiz. Okay? So let's do it again. Now we're flipping coins. So the first thing, which you need to recognize that you need to do first here, NPQ. N is the number of trials. I'm flipping 12 coins, 12 trials. Success, what's the probability of getting tails? 1/2. Failure, 1/2. So the probability of getting 3 tails is 1/2 raised to the 3rd power times 1/2 raised to the 9th power, 12 minus 3, times 12C3. Okay. Rounding to the nearest 1/10 of a percent. Remember, I'm converting to percentages here. 5.4%. Done. Okay. Example 5. Roll 5 dice looking for 3s. Find the probability of getting exactly 3 3s. So define N, P, and Q first. N is 5 because I'm rolling 5 dice. Probability of success, I'm getting a 3. Well, 1/6 chance of getting a 3. Failure is getting anything else. So 5/6 chance of getting anything else. So probability of getting exactly 3 3s. So that's a 1/6 to the 3rd times 5/6, not 1, 5/6 to the 2nd, 5 minus 3, times 5C3. Type that in, round, move the decimal, you get 3.2%. Okay, and there's that. So you can write your 3-sentence summary.